Hi all. As we discussed earlier in my previous lecture video, we had seen the basic terms and its explanations like displacement, distance, velocity, average velocity, instantaneous velocity, and speed. So now I'm going to recall everything. Displacement means it is a shortest distance. Distance means it is the actual distance, means it's the longest distance to reach from A point to B point, means two different points. Okay, and velocity means distance by time. Meter per second is its units. And average velocity means the sum of all velocities divided by the number of instants. Instantaneous velocity means it's velocity founded at certain instant of time, and whereas the speed means rate of change of distance traveled with respect to time. So in this lecture we are going to see about acceleration, average acceleration, and different Newton's laws. So acceleration means it's the rate of change of velocity with respect to time. So you can see that acceleration A is equal to dv by dt. We already know that dv means dx by dt. So the unit of acceleration is meter per second square. And average acceleration. So average acceleration means it is obtained by averaging all different accelerations. So they are saying that if we consider a particle at a certain distance from O at any instant of time, the new position of the particle also we will be knowing. For example, it will become x plus del x from the origin of the velocity of v plus del v, means new velocity if we obtain. So average acceleration over the time is given by del t. So A average is del v by del t, means varying acceleration together. You will be getting the average of varying accelerations at a particular point. The next one is acceleration due to gravity. Acceleration due to gravity means we already know that each and every body is attracted towards the center of the earth by a gravitational force, and the acceleration with which the body is pulled towards the center of the earth is known as acceleration due to gravity. So gravitational force we already came across so many lecture videos in my fourth module also. We already know that gravitational constant means it's g, and the value of g is 9.81 meter per second square, because it's an acceleration due to gravity. So the unit of acceleration is meter per second square. And now we are going to see a very important topic, that is Newton's law of motion. We already aware that Newton's first law, second law, third law, in the first module only we had seen all the detailed things. Here we can see the laws only like a overview. So in the Newton's first law, it states that every body continues in the state of rest or in the uniform motion as long as it is under the influence of balanced force system. So unless or until some external agency is acting on the body, the motion, it will be in a particular motion. So we already knew that it is compelled by external forces. And Newton's second law means F is equal to ma, means the rate of change of momentum of a body is directly proportional to the impressed force, and it takes place in the direction of force acting on it. And third law we already knew that the action and the reaction are equal in magnitude, means for every action there will be equal and opposite reaction. So now we are going to start with the basic definitions or the basic types of motions. So before that, there are two different major methods for calculating the motion. One is graphical representation method, and another one is displacement time graph. And in the graphical representation only we have two types of graphs. One is displacement time graph, another one is velocity time graph. Okay, so in the graphical representation we shall see how to analyze with respect to this graph system. So as like already we have discussed in the methods of motion, so all in very traditional method they will be using this graphical representation for calculating. For example, if your body is starting at one point and reaching at another point, means the initial final points will be there. They will be drawing a graph with respect to the displacement and velocity, and finally they will calculate how much distance the body has been traveled and everything. So here in the displacement time graph, as I said, this is a graph which represents the displacement with respect to time. So it is understood that under the rest, we already know that displacement will be 0 if it is under rest or it is in particular point. But if it travels to some other point, like the position is changing, means you will be obtaining a graph for it. We shall see the different graphs included in the displacement time graph. So here I have displayed 4 different displacement and time graph. So here you can see the variation of displacement with respect to time. So in this graph, we have drawn the x-axis as time and y-axis as displacement. When it is constant, when the body is in particular point, the line will be uniform, means same. So here you can see the displacement and time graph in the uniform manner. But you can, in the next graph, you can see the variations with respect to a steady increase in motion. If your body is steadily going in a particular motion and gradually it is increasing in the same manner, means the graph will look like this. But if in the place that the body is reaching some other point, it is going more like accelerated more, means then you can see the variation will look like a curve. And finally the last one is when you can see that the gradually when the body is starting with more speed and it is ending with a particular like less speed, means the graph will look like this. So these are the 4 different displacement time graphs. And as I said, in the graphical representation only we have velocity time graph. Velocity time graph also you can see that, see, velocity and time is uniform in this graph. As like earlier case, in the y-axis we are taking velocity and x-axis we are taking time. So here you can see T1, T2, V1, V2 means T1 means first instance of time, T2 means second instance of time. At both instance velocity is same, means you can see the graph will be looking like this. And in the next one, gradually at time T1 there is V1, but at T2 it is somewhat it is varying. So but the increasing like the graph is showing that it is increasing with gradual speed. The speed is same, so the velocity is same. So in that case the movement will be in a uniform manner. And the next one is when there are not only 2 instances, the graph will look like this. And finally acceleration with respect to time. So we had seen velocity, and the next one is acceleration. So here you can see the acceleration is uniform with respect to time. So these are the different types of graphs with respect to graphical representation. So in my next presentation, I will be giving a lecture on different types of motions. So in my lecture, in the next lecture video, we can see more about the different types of motions, and we can also see few numericals associated along with the different types of motions. So these are the varying different graphs. I'll continue with my next lecture. Thank you all.